In this video here, we're going to take a look at power. Now we can calculate the power developed by an engine and solve problems about moving vehicles. So power then is simply the rate of doing work. And the power developed by the engine of a moving vehicle is calculated by using the following formula. So power is equal to Fv, where F is the driving force produced by the engine and V is the speed of the vehicle. And if the driving force is measured in newtons and the speed is measured in meters per second, well, power is measured in watts, where 1 watt is 1 joule per second. So in that case, then the power of an engine is often just given in kilowatts. And we give the units here as kW, where the W then is a capital letter. Okay? So in terms of an introduction here to power, we don't actually need much more than that. So the two key points here to take away then is that power is simply the rate of doing work, and that power is equal to Fv, where F is the driving force produced by the engine, and V is the speed of the vehicle. So I think the best way here then to demonstrate this concept of power is to just run through a couple of practice questions. So let's just get started then with question 1 here. All right, so let's just get started here then with question 1. So as we can see here for question 1, right, quite a nice easy question just to get us started. So what we've got here then is a car that's traveling at 10 meters per second and its engine is producing the driving force of 1,200 newtons. So for this question here then, all we want to do is calculate in kilowatts the power developed. So for this question here then, you need to be aware that power is simply Fv here. So F times V. So F is the driving force here, 1,200, times by V, where V is this velocity. Okay? So in that case, then the power developed here is equal to 1,200 times by 10, which is equal to 12,000. Okay? I'll just be very, very careful here, right? So this answer here, this is in watts, but we want the answer in kilowatts. So remember then, 1 kilowatt here is 1,000 watts. So what that means then is the power developed. So the power developed here is simply 12 kilowatts. Okay. And there we have it then. So that gives us the solution there to question 1. So to finish with here then, let's just have a go now at the very last question for this video, question 2. Now, as we can see then for question 2 here, there isn't a whole lot going on. So what we've got here is a car of mass 1,000 kilograms that's traveling along a straight horizontal road against resistances totaling 400 newtons. We're then told that the car's engine is working at 12 kilowatts. And then for this question here, or for the first part of the question anyway, all we want to find then is the acceleration when the car is traveling at 8 meters per second. So for part A here, as we can see, right, we don't have a diagram for this question. So let's just quickly begin here by drawing our own force diagram. Now, it doesn't have to be perfect, by the way. In fact, you don't even need to actually draw a car. You can just draw a box, for example, but I'll draw a car anyway. I'll demonstrate my amazing art skills here. So I've got my car here. Something like this. We've got our wheels. We've got somebody in the car. I'm not sure why they're at such an angle. I've got my steering wheel here and my person. There we go. That's a perfect car. Exactly what it would look like. Beep, beep. There we go. So that's my car. What forces do we have now? So we've got the acceleration here. We just say that's in this direction here. That's a meters per second squared, like so. We've got the total resistances here in this direction. So that's 400 newtons there. We've got the driving force here of the engine. We'll just call that T here. And what else are we missing here? Well, anyway, for part A here, we're told that it's traveling at 8 meters per second. Okay, so 8 meters per second here. Like so. Okay. Now, for part A then, like we said, right, all we want to find here is the acceleration when the car is traveling at 8 meters per second. So to begin with here, we know that power is equal to FV. Okay, well, the power then is 12 kilowatts. So 12 kilowatts is 12,000. So 12,000 is equal to FV. So F here is a driving force, which I've just labeled as T. And we times that by V, which is 8 in this case. Okay. Now we want to solve for T here. And in that case then, nice and straightforward here, T is equal to 12,000 divided by 8. So 12,000 over 8 here, put that into your calculator, that gives us 1,500. Okay, now we're not done here. What we now need to do is use Newton's second law, F equals ma. So now use F equals ma, like so. So F here, if we take to the right as positive then, so taking to the right here as positive, we get T minus 400. So T minus 400 is equal to the mass times the acceleration. So the mass here is 1,000. We get 1,000 here times by A. Okay, like so. Now we know then that T here is 1,500. So I've got 1,500 minus 400. That gives me 1,100 is equal to 1,000A. Okay. And then finally, to finish with here, right, if we just want the acceleration A here, we just do 1,100 divided by 1,000. So 1,100 over 1,000 here. What does that give us then? Okay, 11 over 10, so 1.1 there. Perfect. So 1.1 meters per second squared there. Okay, so hopefully nice and straightforward there for part A. And now for part B of this question here, what we want to do is find the maximum speed of the car. So for the maximum speed here, so for the max speed here, this is when the acceleration A is equal to 0. Okay. So again, if we use Newton's second law here, so again, using F equals ma, then in that case, I get T minus 400 again. So T minus 400 is equal to ma, but A here is 0. So T minus 400 is equal to 0. And in that case, then T here is equal to 400. Okay. And again, if we just use power is equal to FV here. So using power is equal to FV. Then in that case, again, the power here won't change. That's just 12 kilowatts. So 12,000 is equal to FV. So F here is 400. V is just V, right? We don't know what that is. That's what we're looking to solve for. We get 400 V there, like so. And then finally here, we just want to solve for V, right? So V then is equal to 12,000 all over 400. Just put this into your calculator. And if you do this correctly then, what you should get here is 30 meters per second there. Okay. And there we have it then. So hopefully nothing too challenging there. But that gives us the solution here to the very last question for this video, question 2. And that concludes this video here on power.